to SciTech. In this video, I want to do a teardown of this electric tea kettle. I want to see how it works, and I want to see if there's any parts worth salvaging. Let's get started. As you can see, there's a hole in the tea kettle. I accidentally broke the glass by simply washing it and bumping it, creating this hole. However, the rest of the tea kettle works just fine. Taking off this top piece, this little filter is potentially useful, so I'm definitely going to keep that. So I'm going to take that and put it to the side. Maybe even the lid, possibly, not really sure. So I might discard that and might keep just the filter. But for now, keep the two parts together and put it to the side. And now let's go work on the tea kettle. And now do what I always do, see a screw, take a screw, see a screw, take a screw, and remove all of the screws that I can find. And I'll just simply open up the bottom part of the housing, just like this. And as you can see, it's a very simple circuit. This ring right here is the LED ring, which lights up. As you can see, it's just a simple heating coil. And you can see the heating coil is 110 to 120 volts AC and 900 to 1100 watts. And with a wattage this high, I must assume that's hot enough to melt solder, so I can possibly use this to melt solder to be able to attach surface mount components. This can be easily used in a future project. Examine a little more, and this right here is the ground wire. Simply detach it, and now I can remove the bottom housing, which is not needed, so I'll go ahead and discard that. Although maybe I'll keep it, not really sure yet. And now let's go deeper, figuring out how to open up the top part of the housing. Having some difficulty prying off the top housing, just a little bit more force, and there, it comes off just like this. Examine a little bit more, and I can see by taking my pocket knife, I can easily pry off the handle. And there, it comes off just like this, although it broke because I think the bottom part is screwed into place. Or maybe not, it's just attached really well. I can see there are two screws right here, just simply unscrew them and remove the handle. I want to carefully remove this switch. Take my pocket knife, pry it out of the handle, and there, it comes off just like this. This right here is a thermal switch, and with this thermal switch right here, when it gets hot enough, because this is at direct contact with the glass, when it becomes hot enough, it will actually deform due to the heat. And when it deforms from the heat, it'll cause it to deform and push on the switch, which automatically turns it off. So then, when you do this, it doesn't do anything since this is spring-loaded. And since this is somewhat spring-loaded because it's cold, and when it heats up, it deforms from the heat, which acts like a spring. So when I push down on this button, it locks, because there's a spring mechanism that locks it. Push on this, unlocks, and if I leave my finger on it, it doesn't lock. That's a very interesting switch. You can see right here where it pushes. You can see right here how it pushes onto this, and when it heats up, it deforms, which then causes me to not be able to push on it. Interesting. Very interesting. So, if I wanted this to overheat and go out of control, all I would have to do is remove this switch, and then this can overheat and get out of control, and always continue bubbling. So that's interesting. But I don't think I want to do that. Might want to do something like that, where I control it with an Arduino, where it has a timer, or actual physical timer, by estimating how long it takes for water to boil, and then I could just put a timer on this, or attach this onto a hot plate directly underneath, and that way it measures the temperature and turns off. A lot of different things I could possibly use this, so I'm going to keep this intact. So what I'm going to do right now is simply cut this piece off since it's not needed. There we go, this is now trash. I could just detach it, but the wires aren't in very well, so I don't want to mess up with the switch, because I might use it. Now looking at this some more, you can see that there's some blue LEDs. That's very nice. So what I'm going to do is carefully take the LEDs out. And there, this part is now useless. Although, I might use it for something else, because I like how the LED light disperses. So perhaps this can be useful for a future project or something. Not really sure, but I might use it. Put it over to the side, along with the two parts that are useful. This, I want to see how this works, and then put it back together, because I'm probably going to use this with this, and use it together for something. But for now, let's go a little deeper. I want to carefully remove this bottom part. Oh, I see. It's glued into place. I think. I'm not really sure how this is attached. I have to figure out how I can detach this so I can be able to use this as a hot plate. So since I can't get the bottom part removed, I'm just going to go ahead and smash it up. And there, I got this bottom part removed. All I have to do now is just simply chip off this glass carefully. Yeah, this is the hot plate part, and you can see that it's glued into place. So what I need to do is carefully break off these pieces all the way around. And now it's time to remove the small pieces of glass that are glued into place. Simply take some pliers and simply pull them out. Take a flat screwdriver and remove all of the glue and leftover pieces of glass. And as you can see, it looks very clean, very nice. Now it's ready for future projects. Put that to the side, and now examine the bottom part of the device. This looks very interesting, so what I need to do is just simply open it up. As you can see, these use triangular shaped screws. Definitely not going to be able to do that with a normal screwdriver, so I so happen to have this type of screw bit. Simply unscrew it, and there, it comes off just like this. Oh, how very simple and very basic. Pull this part up. And as you can see, it just uses 3 wire connections, which makes sense. It uses ground, live, and neutral wires. Now let's have a closer look and see what kind of wires these are. Identify the connections, and you can see that the center pin right here connects to live, which goes right here. This outer ring connects to neutral, which is right here, which goes over here on this part. And this outer ring right here connects to ground, which connects to that wire right here. And there, now you know which connections are which. And as you can see, it connects just like this. And there, it is now reassembled. Now let's go ahead and plug it in and test it out. And now simply take this piece, place it on. As you can see, it still works, although I have to press it down in order for it to stay in place. Of course, if I were to take maybe a frying pan or a beaker, for example, I can place it on top, which will weigh it down and will allow it to heat up and boil the liquid. And now looking at the switch, you can see that it easily turns on and off. I may replace this switch and use a different device, or maybe use this switch and attach it to this device somehow in order to feel the temperature, and when it gets hot, it'll cause it to switch off automatically so it doesn't overheat. And touching this surface right here, it gets nice and hot, even with it sitting on not all the way. So pushing it down all the way is a good thing, but just letting it sit on it just a little bit, you can see that it still works. So now I'm going to patiently wait and let it get nice and hot. Now let's go see how hot it is. Pour a little bit of water on top. As you can see, it instantly boils, which makes it a very useful hot plate. And these are all the items that I think are very useful. As you can see, these two parts right here are very handy. I can just simply take this piece and place it on, maybe attach a handle to it, so that way I can be able to place it on and off, which can be very handy, or two handles on both sides, enough for it to weigh it down a little bit to keep it balanced, and to prevent it from rocking back and forth. Adding a little bit of weight to it, such as heavy handles, will make it very useful, and maybe I can somehow incorporate this switch to maybe a device that sits on it to prevent it from overheating, or directly to this device. Maybe attaching an Arduino to it, measuring the temperature. I'm not really sure, but I may come up with something very useful for this device. And this part right here is a very good filter. I can possibly use this to filter something. Not really sure, but I might use it for something. And as you can see, these LEDs are also very useful. Might just keep them attached to this device to light up the device to show that it's turned on. Or I'll just remove the LEDs and use it for something else. But for now, I'm just going to keep everything together and then come up with an interesting project that I can use all these devices together. And this little ring right here, I could possibly attach it to this device with the LEDs lighting up just to make it look a little nice and to show that it's turned on. And there you have it. Now you know what's inside of an electric tea kettle, how it works, and what kind of parts that are worth salvaging. Thank you for watching Side High Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified of future Side High Tech videos. Till the next tech, goodbye.